Learn VR MR. Come to the Spatial XR community.
Hello everyone, welcome to the Unity XR cross-platform development tutorial. In the last class, I showed how to configure basic XR interactive functions, including player movement, grabbing objects, and UI interaction. At that time, we first added an XR origin, which is a player object, to the scene. This player object represents the user himself, and it can track the user's head data and hand data. Hand data can be divided into controller input and gesture tracking input. We showed the controller input in the last class. The XR origin player object we added is a player object provided in the official sample package of Unity XR Interaction Toolkit. It has integrated most of the interactive functions. We have introduced it before. An XR interaction process requires two objects to participate. One is interactor and the other is interactable. Because the official player object has integrated most of the interactors required for interaction. So we can configure the corresponding interactable object in the scene to realize a complete interaction process. In this class, we will focus on the player object. Let me introduce some knowledge points about XR origin. I can now hide this player object that integrates most of the interactive functions. Let's first create a simple XR origin player object in the scene. We can right-click in the hierarchy panel of Unity, select XR, and click XR Origin VR here. After clicking, Unity will automatically create an XR Origin player object in the scene. Let's expand this object to see its hierarchical structure. Now, the hierarchical structure of this player object is relatively simple, with only 3 levels. Compared with the fully functional player object we imported before, it is a much simpler structure. Then the script on it is also simplified a lot. Now click on this XR origin object to adjust its position. Let's make some adjustments to the position data in this transform component list. I can directly reset its position data so that this XR origin object is located at the origin position in the world coordinate system, which is the 0, 0, 0 position. So what does XR origin do? Its name origin means origin position. So XR origin is the dot in XR. So what does the dot in XR mean? First of all, XR origin can determine the initial position and initial orientation of the user after entering the program. We can now pull the game window down Now I adjust the position and rotation angle of the XR origin object in the scene window. You can see that when I adjust XR origin, the scene displayed in the game window will also change. Because the game window shows a perspective that the program will see after it is actually running. When we put on the headset to run the program, the picture we see in the headset will be the picture displayed in the game window. Because this XR origin has a main camera child object on it, and main camera is a camera object, which is used to render the scene of the body in Unity. So when I move or rotate the XR origin object, the camera object as a child object will also move and rotate synchronously. The picture captured by the camera will also change accordingly. Therefore, the position of the XR origin object in the scene is equivalent to the initial position of the user experience after entering the program. The initial orientation of the user, that is, the orientation in front of the user, is equivalent to the positive direction of the z-axis of the XR origin object, which is the direction pointed by the blue arrow in the scene. So when we build the Unity scene, we need to set the position and rotation information of the XR origin object so that we can determine where we will live in the scene after running the program, and what initial angle we will use to observe the entire Unity event. I will reset its position and rotation data here. Okay, it is now in this position. I have previously introduced that XR origin can track the data of the current hardware device. In fact, it first obtains the tracking data provided by the real hardware device, and then applies these tracking data to the virtual objects on the player object that are mapped to the real tracking device. For example, there is a camera object on the XR origin object. And we can see that there is a tracked pose driver script on the camera object. When an object is added with the tracked pose driver script, it can be tracked by a real device, and the tracking data provided by the device itself is also an input. The tracked pose driver script on the camera object binds the input of our headset device. When our headset rotates in reality, the position and rotation information tracked by the headset will change accordingly. The change in these data is equivalent to the change in the input of the headset device itself. When the input changes, the corresponding input can be passed to the main camera in the virtual world through the tracked pose driver script here. Then the camera object can synchronize its own position and rotation data according to the input data obtained from the real headset device. In this way, the camera object in the virtual world can synchronize the position and rotation with the headset in the real world. It is equivalent to a mapping relationship between the virtual object and the device being tracked in reality. Now only the camera object on the XR origin object is mapped to the real headset. We will map the controller data later. Mapping the controller data is similar to the operation method, that is, you need to add a tracked pose driver script to a virtual object. And then let this script bind the controller input. In this way, when the controller input changes, the corresponding tracked data can be passed to the mapped virtual object. And then the virtual object can be synchronized with the controller input in reality. The controller input includes the position and rotation of the controller itself and the button input on the controller. Let's focus on the position and rotation of the controller itself. The tracking data itself is a three-dimensional coordinate point data. Just like the position and rotation here, which are a three-dimensional vector composed of data on the three axes of x, y, and z. These three-dimensional data of the tracking path are calculated based on a reference point. That is, there needs to be an origin in the coordinate system. Then the position and rotation data of the headset and the controller itself are the specific values obtained based on the position of this dot. This XR origin is not only the origin under XR, but also the origin referenced by these tracking data. We can modify the tracking origin mode parameter in the XR origin script on the XR origin object to modify the origin type of the tracking data. The most intuitive visual feeling it gives people is that it can control the height of the user after entering the virtual world. There are 3 types to choose from. The default is not specified, device and floor type. Let's first look at the floor type in tracking origin mode. If this type is selected, it will use the ground referenced by the hardware device in reality as the reference point in the virtual world, and then adjust the height of the camera in the virtual world based on this reference point. So, what is the ground referenced by the hardware device? Devices like Quest and Pico will ask you to define the safety boundary when you start the experience. When defining the safety boundary, you will be asked to determine the height of the ground first. The determined ground will later become a reference point for hardware device tracking. And then, the virtual world will also adjust the height of the camera in the virtual world based on this reference point to affect the height of the user in the virtual world. Because the hardware devices in reality will use the ground in the safe zone as the reference point for tracking. If we set the height of the ground in the safe zone to the height of the ground in reality when demarcating the safe zone, this is equivalent to fitting the ground in the safe zone with the real ground. The hardware devices will also use the real ground as the final reference point. When we build a scene in Unity, if we put XR origin at the origin of the world coordinate system, and set the coordinates of the ground in the virtual world to the dot in the world coordinate system, the y-axis of the ground in the virtual world is 0. Because the ground in reality is used as the origin of the entire world coordinate system when the real hardware device tracks it. For the origin, its height, that is, the value on the y-axis, is 0. Therefore, the height of the ground in the virtual world is mapped 1-to-1 to the height of the ground in the real world. That is, the height of the ground in the virtual world is consistent with that in the real world. When we put on the headset and stand on the real ground, it is equivalent to standing on the ground in the virtual world. Because XR origin can obtain the tracking data of the headset device in reality, it can apply the track data to the camera object in the virtual world, so that the position and rotation of the camera object are synchronized with the position and rotation of the headset in the real world. When we put on the headset, our height in the virtual world will be similar to that in the real world. Because in the virtual world, the virtual ground and the real ground have been mapped in position. So the height of the camera in the virtual world is consistent with the height of the camera in the real world. Although we set the y-axis of the XR origin object to 0 in the scene, its child object camera offset, which is an object used to control the position deviation of the camera, has its y-axis set to 1.1176. The main camera object, as a child of the camera offset object, has a height of 0 relative to the parent object. Because the position and rotation of the parent object will directly affect its child objects, we can see that the height of the XR origin is 0, while the height of the camera offset relative to the parent object is 1.1176. So in fact, the height of the camera offset object is 1.1176. As a child object, the height of the camera object relative to the parent object is 0. So in fact, the height of the camera object is consistent with the height of the camera offset object, both of which are 1.1176. The height of this camera is the height we see in the scene window. because we set tracking origin mode to floor. So after the program runs, XR origin will automatically reset the height of camera offset to 0. When its height is reset to 0, because the height of the camera object relative to the object is also 0, so normally the initial height of the camera object should also be 0. But in fact, this is not the case. When we set tracking origin mode to floor, XR origin will use the ground of the safe zone referenced by the device in the real world as the reference point. When XR origin obtains the tracking data of the device, it will set the height of the headset in the virtual world to the height of the headset relative to the ground in the real world. However, the strict statement is actually this. If we set tracking origin mode to floor, the height of the camera in the virtual world will be equal to the height of the XR origin object itself, plus the height between the headset device and the ground of the safe zone. So the height of the camera in the virtual world will consist of two parts, one of which is the height of the XR origin object itself. We can see that the value of the y-axis of the position parameter on its transform component is 0, which means that the height of the current XR origin object itself is also 0. But sometimes we may not necessarily put the XR origin player object at a height of 0. For example, now I have a virtual scene with a building in the scene, and this building has several floors. Assume that the ground height of the first floor is 0, but I put the XR origin player object at a certain position in the second floor. In this case, the height of XR origin itself is definitely not 0. Later, when calculating the height of the camera in the virtual world, the height of XR origin itself must be added. Then let's look at the second part, which is the height of the head display device relative to the ground in the safe zone. Suppose the XR device you use is powerful enough to automatically identify the position of the ground in reality. In this case, it does not need the ground in the safe zone, but only needs to calculate the height of the head display device relative to the ground in reality. But for Quest and Pico, they currently need to define the safety boundary and then determine the height of the ground in the safe zone. In this case, the second part is the height between the headset and the ground in the safe zone. Only when we set the ground height of the safe zone to be the same as the ground height in the real world can it be equivalent to the height between the projection device and the ground in the real world. This point is what everyone needs to pay attention to. Then let's introduce another tracking origin mode, which is device. The floor just introduced uses the ground as the origin of tracking. And this device uses the device itself as the origin of tracking. If the tracking origin mode is set to device, the height of the headset in the virtual world will not add the height between the headset and the ground in reality. Instead, we can manually control the height deviation of the camera in the virtual world through the camera Y offset parameter below. Modifying the value of this camera Y offset parameter can directly affect the position Y value of the camera offset child object of the XR origin object after the program is run. You can see that the two values are exactly the same now. Then we can try to run the program first to see the effect of this device mode. Okay, now we are in the program. At this time, the value of camera offset position Y is 1.1176. The height of the camera object in the scene is actually 1.1176. Now I can change the camera Y offset parameter on the XR origin script. You can see that when I adjust this parameter, the height of the camera in the scene will also change accordingly. I now adjust it to 1.4. When I click on the camera offset object, you can see that the value on its y-axis also becomes 1.4. It is consistent with the camera Y offset parameter set in the XR origin script. When the device mode is selected, we can set the camera Y offset parameter in the XR origin script to control the height of the camera object in the scene. This is the function of tracking origin mode as device mode. Then there is also a not specified mode. If we select this mode, XR origin will decide whether it is device mode or floor mode based on the default tracking mode of the device we are using. The default tracking mode used by 6DoF XR headsets such as Quest and Pico is floor mode, which uses the real ground as the reference point for tracking. When this XR origin object is created, the default tracking mode of the XR origin script on it is not specified. So when we put on the XR headset to run the program, the tracking mode here will be switched to floor mode by default. Now we can test that the height of the camera offset child object is 1.176. We click the Run button. Okay, after entering the scene, you can see that this XR origin script has an additional parameter called current tracking origin. It shows the current tracking mode it is in, which is floor. Now it will use the real ground as the reference point for tracking. That is the origin of tracking. Let's look at this camera offset object. At this time, its height is reset to 0. The height of this main camera object is equivalent to the height between my headset and the ground in reality. This camera object can obtain the position and rotation data of the headset in reality and apply it to the camera object in the virtual world. Okay, so this is the pursuit mode of the floor option. I have tested that if I change the tracking origin mode on the XR origin script to floor, and the current version of my XR interaction toolkit is 3.16, which can be seen here. Then I run this program in streaming mode and find that after entering the program, the camera height in the virtual world will not be added with the height between my headset and the real ground. But normally, according to the floor tracking mode, it will add the height between the headset and the ground in reality. We can run the program to try it. Okay, after entering the program, you can find that the camera offset object is still reset to the position with a height of 0. But at this time, the main camera is located at a very low position in the scene. Normally, if our tracking mode is selected as floor, then the camera height in the scene should be added with the height between the headset and the ground in reality. but now it does not add this height. The strange thing is that we tested the not specified tracking mode before. When we put on the headset and ran the program, it automatically set the tracking mode to the default tracking mode of our device, which is floor mode. Obviously, both are floor mode, but when we set tracking origin mode to floor alone, the height of the camera in this scene does not add the height of the headset from the ground in reality when streaming. I guess this may be a problem with the SDK. If we package this program into the headset and run it and we select floor mode alone, the height of the camera after running the program is also normal. After packaging and running, the height of the camera will be added with the height of the headset from the ground in reality. Since there will be some problems when we set tracking origin mode to floor during streaming, we set it to not specified. In this way, even if it is running in series, it will automatically set the tracking mode to floor mode after entering the program. After running, the height of the camera can also be added with the height of the headset from the ground in reality. In this way, the height of the camera in the virtual world can be consistent with the height of the camera in reality. And the height of the user in the virtual world can be consistent with the height in the real world, enhancing the user's immersive experience. Finally, let's summarize. XR Origin has two main functions. The first function is to determine the initial position and initial orientation of the user after entering the program. The second function is to determine the reference point of the tracking data after running the program. There are two tracking modes, one is floor and the other is device. In the ideal state, the floor mode will use the real ground as the origin of tracking. It can ensure that the height of the camera in the virtual world is consistent with the height of the headset from the ground in the real world, and make the height of the user in the virtual world equal to the height of the user in the real world. If the tracking mode is selected as device, we can manually set the height deviation of the camera object. These are the contents of this lesson. We mainly learned some important knowledge points about the XR Origin player object.